Hello everyone and welcome to another math video. I'm Professor Diwa. In this video, we'll be going over factoring by special products. Our objectives are to factor a perfect square trinomial, factor the difference of two squares, factor the sum or difference of two cubes. Alright, so let's get started. First, we're going to go over perfect square trinomials. Here we have a perfect square trinomial in the form a squared plus 2ab plus b squared. This is equal to parentheses a plus b times parentheses a plus b. This is also equal to parentheses a plus b squared. To factor a perfect square trinomial in this form, we just find the values of a and b and then substitute them into this part of the formula here, where we have parentheses a plus b squared. Next, we have a perfect square trinomial in the form a squared minus 2ab plus b squared. This is equal to parentheses a minus b times parentheses a minus b, which is also equal to parentheses a minus b squared. To factor a perfect square trinomial in this form, we just find the values of a and b, and then we substitute them into this part of the formula, parentheses a minus b squared. For example number 1, factor. For part A, we need to factor the trinomial m squared plus 10m plus 25. First, I rewrote this trinomial as m squared plus 2 times m times 5 plus 5 squared. I rewrote this so that you can see that it matches our first formula for a perfect square trinomial. We're going to use that formula to factor this. So what we need to do is find our value for a and b. Now, because I rewrote it in this format, you could see our value for a would be m, and our value for b would be 5. However, if I didn't rewrite it in this format, to find your value for a, we just take the square root of the first term, m squared. This would just be m, so I have a is equal to m. Next, to find the value for b, we just take the square root of the third term, 25. The square root of 25 is 5, so b is equal to 5. To factor, we just substitute these values into our formula, parentheses a plus b squared. Our final answer is parentheses m plus 5 squared. Next, we move on to part b. We have 3a squared x minus 12abx plus 12b squared x. This trinomial is not in the perfect square format, so what we're going to do is factor out a common factor of 3x. We get 3x times the parentheses a squared minus 4ab plus 4b squared. Now you can see the trinomial inside the parentheses is a perfect square. To find the value of a, we take the square root of the first term, a squared. This will just be a, so a is equal to a. To find our value for b, we take the square root of the third term, 4b squared. We get 2b, so b is equal to 2b. Next, we substitute these values into our second formula, which is parentheses a minus b squared. For our final answer, we get 3x times the parentheses a minus 2b squared. Next, we have a practice problem, factor. For part A, we have the trinomial x squared plus 8x plus 16. For part B, we have 4x cubed minus 32x squared y plus 64xy squared. So go ahead and pause the video, try out this problem, and then check back with the video to see the answers. To factor part A, we need to find our values for a and b. We just take the square root of the first term x squared, which is x, so a will be equal to x. We take the square root of the third term, 16, which is 4, so b is equal to 4. We substitute our values into the formula, parentheses a plus b squared. We get our final answer, which is parentheses x plus 4 squared. For part b, we start by factoring out the common factor of 4x. We get 4x times the parentheses x squared minus 8xy plus 16y squared. Next, we factor the perfect square inside of the parentheses. We take the square root of the first term x squared, which is just x, so a will equal x. we take the square root of the third term, 16y squared. This will be 4y, so b is equal to 4y. We substitute this into the formula, parentheses a minus b squared. Our final answer is 4x times the parentheses x minus 4y squared. Next, we're going to go over factoring a difference of squares. A difference of squares has the form a squared minus b squared. This is equal to parentheses a minus b times parentheses a plus b. To factor a difference of squares, we just find the value of a and b and substitute it into the formula parentheses a minus b times parentheses a plus b. For example number 2, factor. For part A, we have x squared minus 49. I rewrote this as x squared minus 7 squared, just so you could see that this is definitely a difference of squares. To factor this, we find our value for a and b. We start by taking the square root of x squared, which is x, so we get a is equal to x, and then we take the square root of 49, which is 7, so b is equal to 7. Next, we substitute our values for a and b into the formula parentheses a minus b times the parentheses a plus b. We get our final answer as parentheses x minus 7 times the parentheses x plus 7. Moving on to part B, we have y to the fourth power minus 16. To factor this, we start by taking the square root of the first term, y to the fourth power. This is going to be y squared. So a is equal to y squared. Next, we take the square root of 16, which is 4, so we have b is equal to 4. Next, we plug in our values of a and b into our formula. We get parentheses y squared minus 4 times the parentheses y squared plus 4. You can see here that the first factor, y squared minus 4, is also a difference of squares. So that means that this could be factored further. To find the value of a, we take the square root of y squared, which is y, so a is equal to y. To find the value of b, we take the square root of 4, which is 2, so b is equal to 2, and we plug those values into our formula. We get our final answer, which is parentheses y minus 2 times the parentheses y plus 2 times the parentheses y squared plus 4. Moving on to part C, we have 1 over 16 minus 25z squared. We find a by taking the square root of 1 over 16, which is 1 over 4. To find the value of b, we just take the square root of 25z squared, which is 5z. So a is equal to 1 over 4, and b is equal to 5z. From here, we substitute our values for a and b into our formula. We get our answer, which is parentheses 1 over 4 minus 5z times the parentheses 1 over 4 plus 5z. Next, we have a practice problem, factor. For part A, we have x squared minus 9. For part B, we have a to the fourth power minus 81. For part C, we have y squared minus 1 over 64. Alright, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's get started with part A. The first thing we need to do to factor is find our values for a and b. Our value for a is x, and our value for b is 3. Next, we substitute it into the difference of squares formula. We get parentheses x minus 3 times parentheses x plus 3. For part B, our value for a is a squared, and our value for b is 9. We substitute it into our difference of squares formula. We get parentheses a squared minus 9 times parentheses a squared plus 9. The first factor, a squared minus 9, is also a difference of squares, so we can factor this further. Our value for a is a, and our value for b is going to be 3. Substitute this into our difference of squares formula. We get our final answer, which is parentheses a minus 3 times parentheses a plus 3 times parentheses a squared plus 9. For part C, our value for a is y, and our value for b is 1 over 8. Next, we substitute these values into our difference of squares formula. We get parentheses y minus 1 over 8 times parentheses y plus 1 over 8. For example number 3, factor. For part A, we have parentheses x plus 3 squared minus 64. To factor this, we use our difference of squares formula. First, we need to find our values for A and B. To find our value for A, we take the square root of the parentheses x plus 3 squared. This is just x plus 3, so A is equal to x plus 3. Next, we need to find our value for B. We take the square root of 64, which is 8, so B is equal to 8. Next, we substitute our values for A and B into the difference of squares formula. We get parentheses, another set of parentheses, x plus 3, minus 8, times parentheses, another set of parentheses, x plus 3, plus 8. From here, we simplify by dropping the inner parentheses and combining like terms. The final answer is parentheses x minus 5 times parentheses x plus 11. Moving on to part B, we have x squared plus 4x plus 4 minus y squared. What we're going to do first is group together the first three terms because the first three terms is a perfect square trinomial. So I have parentheses x squared plus 4x plus 4 minus y squared. Next, we factor the trinomial inside the parentheses using the perfect square formula. To find our value for A, we take the square root of x squared, which is x. To find the value of B, we take the square root of 4, which is 2. We plug our values into the perfect square formula, parentheses a plus b squared. The result is parentheses x plus 2 squared, and then we bring down the minus y squared. You can see here that we have a difference of squares, so we factor this using the difference of squares formula. First, we find our value for A, which is going to be the square root of x plus 2 squared. We get A is equal to x plus 2. Next, we find our value for B, which is going to be the square root of y squared, so B is equal to y. Next, we substitute our values for A and B into the difference of squares formula. We get parentheses x plus 2 minus y times the parentheses x plus 2 plus y. Next, we have a practice problem, factor. For part A, we have the parentheses x plus 1 squared minus 9. For part B, we have a squared plus 2a plus 1 minus b squared. Okay, so go ahead and pause the video, try out this problem, and then check back with the video to see the solutions. Alright, so let's go over part A. To factor this, we use our difference of squares formula and we find our values for A and B. Our value for A is x plus 1, our value for B is 3. When we factor this, we get parentheses, another set of parentheses, x plus 1 minus 3, times the parentheses, another set of parentheses, x plus 1 plus 3. Next, we simplify by getting rid of the inner parentheses and combining like terms. We get our final answer is parentheses x minus 2 times parentheses x plus 4. Moving on to part B, first we group together the first three terms, a squared plus 2a plus 1. This is a perfect square trinomial, so we factor this using the formula for a perfect square. Our value for a is a, and our value for b is 1. We plug in our values for a and b into the perfect square formula. We get parentheses a plus 1 squared, and we bring down the minus b squared. From here, we factor this as a difference of squares. Our value for a is a plus 1, and our value for b is b. We substitute our values for a and b into the difference of squares formula. We get parentheses a plus 1 minus b times the parentheses a plus 1 plus b. Next, we're going to go over how to factor a sum and difference of two cubes. First, we have the sum of cubes, which is a cubed plus b cubed. This is equal to parentheses a plus b times parentheses a squared minus ab plus b squared. Next, we have a difference of cubes, which is written as a cubed minus b cubed equals parentheses a minus b times parentheses a squared plus ab plus b squared. To factor a sum or difference of cubes, we just find the values for a and b, and then we substitute it into the corresponding formulas. Next, we have example number 4, factor. For part A, we have x cubed plus 8. To factor this, we use the sum of cubes formula. We find our value for A by taking the cube root of x cubed, which is x, and we find our value for B by taking the cube root of 8, which is 2. So A is equal to x and B is equal to 2. Next, we substitute our values for A and B into our sum of cubes formula. Our final answer is parentheses x plus 2 times parentheses x squared minus 2x plus 4. Moving on to part B, we have y cubed minus 27. To factor this, we need to use the difference of cubes formula. First, we need to find A and B. To find A, we take the cube root of y cubed. This is y. To find B, we take the cube root of 27, which is 3. So A is equal to y and B is equal to 3. Next, we substitute our values for A and B into the difference of cubes formula. The result is parentheses y minus 3 times parentheses y squared plus 3y plus 9. Moving on to part C, we have p cubed minus 8q cubed. To factor this, we need to use the difference of cubes formula. First, we need to find our values for A and B. To find the value of A, we take the cube root of p cubed, which is p. To find the value of B, we take the cube root of 8q cubed. This is 2q. So our value for A is p, and our value for B is 2q. Next, we substitute our values for A and B into the difference of cubes formula. We get our final answer is parentheses p minus 2q times parentheses p squared plus 2pq plus 4q squared. Next, we have a practice problem, factor. For part A, we have x cubed minus 64. For part B, we have y cubed plus 1. For part C, we have x cubed plus 125y cubed. Alright, so go ahead and pause the video, factor each problem, and then check back with the video to see the answers. Alright, so let's go over part A. For part A, we have a difference of cubes. Our value for A is x, and our value for B is 4. Substituting our values for A and B into the difference of cubes formula, we have parentheses x minus 4 times parentheses x squared plus 4x plus 16. Moving on to part B, we have a sum of cubes. Our value for A is y, and our value for B is 1. Substituting our values into the sum of cubes formula, we have parentheses y plus 1 times parentheses y squared minus y plus 1. Moving on to part C, we have a sum of cubes. Our value for A is x, and our value for B is 5y. Substituting our values into the sum of cubes formula, we get parentheses x plus 5y times parentheses x squared minus 5xy plus 25y squared. Next, we have example number 5, factor. We have 125q squared minus n cubed q squared. First, we need to factor out a common factor of q squared. We have q squared times parentheses 125 minus n cubed. You could see inside the parentheses we have a difference of cubes, so we factor this using the difference of cubes formula. First, we find our value for A, which is the cube root of 125, so A is equal to 5. Next, we find our value for B, which is the cube root of n cubed, so B is equal to n. Next, we bring down the q squared, and then we substitute our values for A and B into the difference of cubes formula. We have our final answer, which is q squared times the parentheses 5 minus n times the parentheses 25 plus 5n plus n squared. Next, we have a practice problem, factor 27a squared minus b cubed a squared. Go ahead and pause the video, try factoring out this problem, and then check back with the video to see the solutions. Alright, so let's go over the practice problem. First, we need to factor out a common factor of a squared. we have a squared times the parentheses 27 minus b cubed. You could see here that we have a difference of cubes inside the parentheses. Our value for a is 3, and our value for b is b. Next, we bring down the a squared, and we substitute our values for a and b into the difference of cubes formula. We get our final answer, which is a squared times the parentheses 3 minus b times the parentheses 9 plus 3b plus b squared. Alright, so this is the end of our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.